Number 1. Oxidation. Pyridine is not affected by mild oxidizing agents like chromic acid or nitric acid. However, when it is treated with a strong oxidizing agent like peracetic acid, it undergoes oxidation at the nitrogen atom to form Pyridine-N-oxide. Well, to understand how this oxidation works out, we need to understand three things. Number 1, what is peroxy acid and how peracetic acid is formed. Number 2, how the peracetic acid decomposes itself to yield nascent oxygen. And number 3, in what form the interaction takes place between nascent oxygen and the nitrogen of the pyridine ring to produce Pyridine-N-oxide. Number 1. What is peroxy acid? Peroxy acid is referred to as this group OOH. It is a very strong acid because the combined electronegativity of two oxygen atoms easily knocks out an H plus from the molecule. This group, the COOH, is referred to as the peroxy derivative of carboxylic acid, and the molecule as a whole is peroxy derivative of acetic acid or peracetic acid. How is it formed? Synthesis of peracetic acid. To form peracetic acid, you just need to treat acetic acid with hydrogen peroxide. The carbon double bond O of acetic acid is a highly polar one. This is because there is a difference in electronegativity of the two atoms involved in the bond. Oxygen is highly electronegative and therefore it pulls the electron pair that it shares with the carbon towards it, resulting in a negative charge over oxygen and a positive charge over the carbon. The positively charged carbon atom now acts as a Lewis acid and attracts a lone pair of electron from either of the oxygen of hydrogen peroxide. When it attracts, it restores its neutrality. But the oxygen which donates the lone pair, because it has lost its lone pair to carbon, becomes positively charged. To become neutral and to be stable, the oxygen now pulls the electron pair that it shares with the hydrogen, and that restores the neutrality in the oxygen atom. A problem persists on the other end of the molecule, where in the carbonyl oxygen, where an electron pair persists. This electron pair is shared with the carbonyl carbon, and this is shared because the oxygen wants to become neutral. However, when it is shared in covalent bond with this carbon, the carbon eliminates the electron pair that it shares with OH, along with OH. This is because the carbon can have a maximum of 8 electrons in the outermost shell, and this results in the formation of peracetic acid. The OH minus that is eliminated combines with H plus that was eliminated in the preceding step to form the H2O. Now, as the peracetic acid is formed, how does it decompose itself to produce nascent oxygen? The peracetic acid contains the carbonyl group. The carbon double bond O is a highly polar bond. This is because of the difference in electronegativity of the two atoms. The oxygen is highly electronegative, therefore it withdraws the electron pair that it shares with the carbon, thus becoming negative in charge. The carbon, because it has lost its bonding pair of electron, becomes positive in charge. The positively charged carbon atom now attracts the lone pair of electron of the neighboring oxygen towards itself, thus establishing a second covalent bond with this oxygen. However, because this oxygen lost its lone pair of electron to the carbon, the oxygen here becomes positive. To restore neutrality, this oxygen attracts and snatches the bonding pair of electron that it shared with this oxygen, and that results in the formation of an acetate ion. You can see how the double bond is established between the carbon and oxygen and how neutrality has been restored in this oxygen. But because this oxygen lost its bonding pair to this oxygen becomes positive. Now, this positively charged oxygen, as to become neutral, snatches away the electron pair that it shares with the hydrogen, resulting in the formation of nascent oxygen and elimination of H plus ion. The eliminated H plus ion combines with the carbonyl oxygen to produce acetic acid, and thus peracetic acid decomposes itself to produce nascent oxygen. Yes, a nascent oxygen is produced by the decomposition of peracetic acid. A nascent oxygen is a singular oxygen atom that has been produced by decomposition or any other chemical reaction. Its atomic number is 8. Atomic number 8 means that it has got 8 electrons, which is arranged as such in the orbitals. The molecular orbital picture clearly shows that it is in desperate need of 2 more electrons to complete its octet configuration. Let us now look at the situation of nitrogen atom in pyridine. The nitrogen atom in pyridine has already completed its octet and it is in no need of any kind of bond formation. The nitrogen atom here is sp2 hybridized. sp2 hybridized means that there are 3 sp2 hybrid orbitals in this nitrogen. One of the sp2 hybrid orbitals consists of the lone pair of electron. The other 2 sp2 hybrid orbitals are overlapping with the sp2 hybrid orbitals of carbon atoms on either side, forming the sigma covalent bond. Yes, there is an unhybridized p orbital in the nitrogen atom, and this is free to show lateral overlap with the unhybridized pz orbitals of carbon atoms on either side, thus forming the pi bond and thus forming a part of delocalization. In short, the nitrogen's octet is already complete. 1, 2, 3, 4, 5, 6, 7, 8. And therefore, it is in no need of any kind of covalent bond formation. The picture here, however, is different. The oxygen is in desperate need of 2 more electrons. This is the first reason that oxygen attacks the nitrogen atom. The second reason for the attack is that oxygen is more electronegative than nitrogen, and therefore oxygen attracts the electron pair that is available on the nitrogen. The third reason for the attack is that the lone pair of electron is localized on the sp2 hybrid orbital. The lone pair of electron on sp2 hybrid orbital does not take part in delocalization of the electron. It is localized, it is readily available for donation, and therefore the nitrogen donates the lone pair of electron to oxygen. Because the nitrogen has completely donated a pair of electron to oxygen, it develops a positive charge and the oxygen develops a negative charge, and the result, the product is Pyridine-N-oxide. In a coordinate covalent bond, out of the 2 electrons that are donated, one of the electron is under the complete influence of the donor atom, the other electron is under the complete influence of the acceptor atom. That explains the unit charges that are developed on the atoms involved in the coordinate covalent bond.